Start. Om Swastiastu. Thank you for joining us today. We are delighted to present the result of our group final project for the database courses. Our project focuses on designing a database system for Warung Sida. First, let us introduce ourselves. We are from Group 2 that consists of 4 people. There are me, Sapta, as moderator. The second one is Pito as speaker 1. The third one is Aris as speaker 2. And the last one is Herman as speaker 3. Before we begin, let's clarify our objective for the project. Our goal was to develop a well-structured and efficient database system that supports the recording of transactions that occurs in Rahayu. In this presentation, we will cover 3 main aspects of our project: the entity relationship diagram, or ERD, the normalization process, and the final database implementation. And the contents of this presentation is the first one, analysis of the current system. So the Warung Sida Rahayu overview and analysis of the current system. The second one is system implementation. And the last one is Warung overview. So the Warung Sida Rahayu is a small food stall located on Jalan Abimanyu Singaraja. It offers a diverse range of food and drinks that cater specifically to students. The menu includes popular items such as spicy chicken rice, tempong rice, lalapan, iced tea, extra juice, and more. Currently, the food stall relies on a manual system using notes for its day-to-day operations. So let's analyze the strength and weakness of this current system. So the strength is, the first one is affordability. Warung Sida Rahayu offers reasonably prices food, drink, and making it an attractive option for students with limited budgets. The second one is menu variety. The food stall provides a diverse range of menu items, ensuring there are options to suit different tastes and dietary preference. And the last one is convenient location. Its strategic location near student areas make it easily accessible and convenient for students to visit. And the weakness is, the first one is the manual system. Because of the manual system, the current reliance on a manual system using notes can lead to inefficiencies such as delay in order, processing, and difficulties in tracking inventories. The second one is limited information management. With the manual system, there may be challenges in managing customer information, order history, and sales data, which could hinder decision making and business analysis. The third one is inventory management. Tracking and managing inventory manually can be time consuming and prone to errors, leading to issues such as stock out or overstocking. And the last one is inefficient order processing. Without a digital system, the process of taking and processing order may be slower, potentially resulting in longer waiting times for customers. So the system implementation, the information system overview. In implementing a database to support data management for Warung Sida Rahayu, the first step is to create an ERD, or entity relationship diagram, to guide the database creation process and provide an initial design. Once the ERD is finalized, the next step is to build the database based on the ERD and input the relevant data required for effective Warung Sida Rahayu data management. So the step is customer order placement, order processing, item processing, and the last one is payment. So this is the table relation of our database. So to explain this database, we start with the customer, between customer and orders. The customer represents primary key customer ID in the customer table. This connection allows each order in the customer table. By referencing the primary key, it ensures that the value in the customer ID column of the orders table corresponds to an existing customer ID in customer table. This relationship enables the retrieval of customer information for a particular order and allows for data integrity and consistency. The second one is the connection between employees and order. The order ID column in the employees table is a foreign key that references the primary key order ID in the order table. This connection establishes a relationship between employees and the order they are associated with. It allows the employees table to track which orders an employee is responsible for. By referencing the form of the employees table correspond to an existing order ID in the order table. And the next is menu categories and menu item. The category ID column in the menu item table is a foreign key that references the primary key categories ID in the menu categories table. This connection associates each menu in the menu items with a specific category from the menu categories table. It enables categorizing and organizing menu item based on their respective categories. By referencing the primary key, it ensures that the value in the category ID column of the menu item tables correspond to an existing category ID in the menu table. And fourth one is order and order item. The order ID column in the order items table is a foreign key that references the primary key order ID in the order tables. This connection establishes a relationship between order and the item included in each order. It allows the order item table to associate specific item with a particular order. By referencing the primary key, it ensures that the value in the order ID column of the order item tables correspond to an existing order ID in the order table. The fifth is order and receipt. The order ID column in the receipt table is a foreign key that references the primary key order ID in the order table. This connection links its receipt in the receipt table to the corresponding order in the order tables. By enables tracking and associating receipt with specific orders, by referencing the primary key, it ensures that the value in the order ID columns the receipt table correspond to an existing order ID in order tables. And the last one is order and transaction. The order ID columns in the transaction table is a foreign key that references the primary key or ID in the order table. This connection establishes a relationship between orders and the transaction associated with them. It allows the transaction table to link to the specific transaction to the corresponding orders. By referencing the primary key, it ensures that the value in the order ID columns of the transaction table correspond to an existing order ID in the order table. So this connection between foreign key and primary key enabled the establishment of relationship and enforce referential integrity within the database. They allow for the retrieval and manipulation of related data across multiple tables and ensure data consistency and accuracy. So the next one is ERD design. For the explanation of ERD design, I will keep it time for Vito. For Vito, the time is yours.
Okay, thank you, Sapta. So now I will explain about the relationship of the ERD and their corresponding action in the ERD. So the first one, we have the customer have a one-to-many relationship with orders. So this means that a customer can place multiple orders, that the action represented by this relationship is that a customer can create multiple orders. Second one is the employee have a one-to-many relationship with orders. This means that an employee can handle multiple orders. So this action represented by this relationship is that an employee can process multiple orders. The third one is order have a one-to-many relationship with order items. This means that an order can contain multiple order items. So the action represented by this relationship is that an order can consist of multiple items. The fourth one is the order have a one-to-one relationship with receipt. This means that each order has a corresponding receipt. The action represented by this relationship is that an order generates a receipt. Orders have a one-to-one relationship with a transaction. This means that each order has a corresponding transaction. So that means the action represented by this relationship is that an order is associated with a transaction. The sixth one is a menu category have a one-to-many relationship with menu item. This means that a menu category can include multiple menu items. So the action represented by the relationship is that a menu category can have multiple items. And the second one is the menu item have a one-to-many relationship with order items. So this means that a menu item can be part of multiple order items. So the action represented by this relationship is that a menu item can appear in multiple orders. The eighth one is the order generate receipt. This action represents the process of an order generating a receipt. And the last one is the customers receive receipt after paying. This action represents the step where customer receive the generated receipt after making payment. So this relationship and action illustrate the interaction and dependencies between entities in the ERD, providing a clear understanding of how different elements in the database are connected and the operation they represent. So because the explanation have done, I will hand it back to Sapta.
Okay, I think that's all for the explanation of the ERD design. So for the next topic is table and normalization. For the table and normalization explanation, I will give it to Aris. For Aris, the time is yours to explain this topic. Thank you.
Okay, thank you for the time. I will explain the about table and normalization. Normalization is a process used to organize and structure data in database by eliminating redundancy and improving data integrity. For the normalization to first number form, we have identified the main entities or object in the table data. Create the spread table for the X entity with the unique attribute represent as a column. Ensure as a table contain only unique row and single values. Assign a unique primary key to each table to identify row uniquely. And then for the normalization second number form, make sure that table already in first number form. Now we identify the function dependency between attribute in the H table. If any attribute are the partially dependent on the primary key, move them to the spare table. Ensure that every attribute in the new table is fully dependent on the corresponding primary key. And then for normalization to third number form, ensure the table already in the second number form. Now we identify transitive dependency between attribute in the H table. If any attribute depends on the non-key attribute, drop another attribute move into spread table. Make sure every attribute in the new table depends directly on the primary key without any transitive dependency. By following the step, normalization help eliminate to data duplicate, anomalies, and inconsistent in the table, making them more structure efficient and maintain data integrity. Okay, this explain about the table and normalization. I throw the moderator.
Okay, that's all for the table and normalization explanation. For the next one is the highlight queries, which will be continued by Herman. For Herman, the time is yours.
Well, thank you, Sapta, for the time. Now, I would like to explain about highlight queries. First, we will show a query that display order from a customer named Sarah. Well, for the for the examples, sales orders item, quantity, menu item, menu name menu item, description menu item, price. From order items, orders, menu items, customers, where order items, order order ID equals orders ID, and orders item ID equals menu items ID, and orders customers ID equals customers ID, and customer name equals Sarah. Next. Well, next we will show a query that display the name of customer who spend more than 20,000, 25,000 in a single order, along with the menu name, order, and the total cost they incurred. For the example, sales customer name, menu items, menu names, order items, subtotal from customers, join orders on customer ID equals customers ID, join orders item on orders ID equals orders ID, join menu items on orders item ID equals menu item ID, where's orders total amount 25 2500 25,000. And next, we will show a query that rectify the information of customer's name, order date, total cost, service employee names, payment method, and payment status, replacing one with paid from the receipt table. For example, select customer's name, receipt, receipt date, receipt total amount, employee's name, receipt, payment method, case, receipts, LS paid, is paid, when one then paid, else not paid, and as is paid from customer join receipt on customer ID equal receipt customer ID join employee on receipts employee ID equals employee ID. Next. And then we will show a query that rectifies orders between July 7, 2023 and July 9, 20 and 2023 from the orders table. For the example, select start from orders where orders date between 2023 7/7 and 2023 or 7/9. And next, we'll show a query that display the name of the customer with the highest number of order along with the total order date and menu name order. For the example, select customer name, orders, total amount, order date, menu item, menu name from customer, join order on customer ID equal orders customer ID, join orders item on orders order ID equal order items, order ID, join menu item on order item ID equals menu item ID, group by customer ID, order by count stars description desk limit 1. Well, that's about all about highlight query. I throw back to the moderator. Thank you.
Okay, thank you for the presentation from our group. So we have a conclusion from this presentation. So the conclusion of this our group final project is focused on designing a database system for Warung Sida Rahayu through the ERD normalization process and database implementation. We created a well-structured and efficient database that meets their specific requirements. We are proud of our achievements and the collaborative efforts that went into this project. We believe our work reflects the knowledge and skills we gained throughout the database course. Thank you for your attention, and so sorry for if there was any mistake. Om Santi 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 Om.